Welcome to this TSAS Tech Talk regarding fuses. Today, let's talk about fuses. Specifically, low voltage power fuses, those for use between 0 and 600 volts AC or DC. Everyone knows what a fuse is, right? Fuses are simple and reliable forms of overcurrent protected devices, or OCPDs for short. They come in a myriad of configurations, sizes, and ratings. In general, fuses are a fusible link or element encased in a tube or housing and connected to terminals. The link has a resistance that is very low and acts as a conductor until it encounters current levels that exceed its amp rating. When the rating is exceeded, the link melts and opens a circuit to protect conductors, components, and loads connected to the power through the fuse. To know how to apply fuses, one must know a little about fusology. No, it's not a made-up word. Fusology is defined as the study of a fuse's operating principles. A fuse's operating principles will shape its unique role in circuit protection. These principles include ratings, operating characteristics, and constructions, which allow the fuse to act as a highly effective overcurrent protective device. Paul Fremel was a professional engineer from the mid-1960s until his passing in 2015. He was known as the Professor of Overcurrent Protection and was a large advocate for fuses instead of circuit breakers. Fremel taught the 3 C's of overcurrent protection, which have come to be known as Fremel's laws of overcurrent protection. It must be said that these laws are not the only consideration in applying OCPDs, but an understanding of these 3 key concepts will lead to safer, more reliable, and code-compliant electrical systems. The 3 laws are: interrupt rating capacity. OCPDs shall be applied with an interrupting rating equal to or greater than the maximum available fault current. Component protection. OCPDs shall be selected and installed to clear a fault without extensive damage to electrical equipment and components. And selective coordination. A properly engineered and installed electrical system will restrict outages to only the nearest upstream OCPD for the full range of overcurrents and associated opening times, leaving the remainder of the system undisturbed and preserving service continuity. We are going to discuss 2 key areas regarding fuses: selection and installation. Now let's keep Fremel's laws in mind as we focus on selection. Foremost, always be sure to only use fuses that bear CSA or equivalent approval markings. When selecting fuses, one must pay attention to the type of fuse and the ratings of the fuse. There are several types or classes of fuse, each with distinct characteristics that make them specific for their intended use. Examples of fuse classes include, but are not limited to, HRC1 and HRC2, which are high rupture capacity fuses. Class H or K are general purpose, non-current limiting, non-time delay fuses with 10,000 amp interrupt rating as a minimum. Class R are general use current limiting with optional time delay fusing and 200,000 to 300,000 amp interrupt rating. Finally, Class L are non-renewable current limiting time delay fuses which are bolt-in and have 200,000 to 300,000 amp interrupt rating capacity. Remember, if you are replacing fuses, one type of fuse should never be replaced with a different type of fuse unless it is the exact same characteristics or there is a specific exemption that exists in the Canadian Electrical Code. Every fuse has several ratings and characteristics associated with it. Not all ratings and characteristics may be identified on the fuse itself. It is imperative that all ratings of the fuse match the needs of the system in which it is being installed. Ratings and characteristics of fuses include voltage rating, amperage rating, interrupt rating, I²T, peak let-through current, melting time, total clearing time, time delay, current limiting, and dual element. The ratings of most concern should be voltage rating, amperage rating, interrupt rating, and time delay. Let's talk about these most important characteristics. Voltage rating is the maximum voltage that a fuse should be subject to in order to carry current and/or clear a fault. Fuses should have a voltage rating equal to or greater than the voltage of the electrical system. Be aware that a fuse rated for X volts AC may not have the same DC voltage rating, so pay attention. If a fuse does not have a rated marking for the current type, don't assume it is of the proper voltage. Either research the voltage rating of the fuse or don't use it at all. Amperage rating is the amount of amps that can flow through the fuse before it will open. Fuse sizes in amps should be adequate for the type of installation. The size of the service, feeder, branch circuit conductors, and the loads supplied will determine the proper size of fuse selection. Interrupting rating is the current that the fuse is able to interrupt without being violently destroyed or causing an electric arc with unacceptable duration. Fuses should have an interrupt rating equal to or greater than the maximum fault current available at the fuse's point of application. Fuses have interrupt ratings from 10,000 amps to 300,000 amps. Time delay is the minimum opening time relative to the overload current magnitude. Fuses are available in time delay and non-time delay versions. Time delay fuses are usually used for inductive circuits, such as motors and transformers that have inrush currents on start. Time delay fuses are also used on power distribution circuits to quickly open and reduce the amount of time the current is allowed to supply an electric arc. When properly designed, this faster clearing time reduces the incident energy. Clearly, there's a lot of thought and coordination to selection of fuses for their ratings and characteristics, and changing any one of those factors can greatly impact the circuit and equipment. Never use a dummy fuse, copper slug, length of wire, or anything else as a permanent fuse substitute, or even as an interim fix until the exact match fuses arrive. Use of fuse substitutes can cause non-operation and equipment damage. Of equal, if not greater concern, would be an improper operation, leading to a violent failure, creating arc blast and molten metal spraying about. Here are a few tips when installing fuses. Always de-energize before pulling or reinstalling fuses. Be sure to observe the installation. Look for discoloration as a sign of excessive heat or poor contact. Look for corrosion, which may hamper clean contact between the fuse and the fuse holder and may be a sign of future issues. When replacing fuses, the fuse holders should never be altered or forced to accept fuses that are not designed for such replacement. Finally, ensure solid contact is made between fuse holders and the fuse blade or end cap. Now you know the ins and outs of selecting and installing fuses. Remember, selecting the right fuse for the job and making sure it is installed correctly will ensure a safe, properly protected circuit. That's all for now. Hope you found this TSASC Tech Talk informative. Have a great and safe day.